David Smith here with one more flipped classroom math video. 3 tips before we start. First, remember you can speed up the playback if that helps you get through the video faster. Just make sure you understand and keep up with your notes. Second, you can pause the video at any time to catch up with your notes or think about the topics. Lastly, you can turn on the captions and watch my words go by on the bottom of your screen. Today's lesson covers how to draw a best fit line with a scatter plot of data. So when we have correlation, when we have trends in our data, it's often useful to draw a line that would express that correlation. And in fact, we can write equations of those lines. So you can see I've got a scatter plot. This is real data, or could be real data. I just made it up, but it could be real data. And we're just a simple time versus speed graph, perhaps for an accelerating object. So what we're going to do is we're going to try to draw a best fit line for there. Now you could just take your pen and go, yeah, like that. But we have a little bit more of a scientific method for doing that. So there's 3 steps. Check this out. First off, start with a scatter plot. Shazam, you got that. 2, find the mean point. So in this case, I'm just going to assume a certain point is the mean point, but I'm going to show you how to calculate that in a minute. But here we go. So let's just assume that that is the mean point. Third, draw a straight line through the mean point and as close as possible to all the other data points. Okay? So the way to do that is to draw your straight line so that an equal amount of these scatterplot points are above and are below that line. So let's see how good I do. Now you be the judge. I think that's pretty good. It looks like roughly half the data is above that line and half the data is below that line. Plus you can see I'm going right through. There's 3 of them and I'm pretty close to 2, 3, 4, 5 more. So that seems like that's a pretty good fit. So this would be a best fit line for this data. Now let's get into the details and do it more mathematically. All right, here is a possible scenario where we have time spent studying in hours graphed against or put against the test score. So we have these various test scores and the hours spent studying. And if you snoop on this data, you're going to notice it's not a perfect correlation in that this person studied 6 hours, got a 78. This one studied 2 hours left, got 2 hours less, but got 2% more. This person studied 7 hours and only got 6% more than that person, and so on. So you can see that this data is not going to make a perfect line. Okay, so step 1 in drawing a best fit line for this data is to make the scatter plot. So I want you to pause the video and go ahead and make a scatter plot in your notes. Okay, here's my scatter plot. And notice how, since our lowest test score is 66, I started my scale at 60 with the scale break symbol right in there. So that's a good trick to do that. And I just scaled it up by 10% each time. And then I really only needed all the way up to 8 hours. So I scaled my x-axis just starting at 8 or ending at 8. And then I plotted all my points on there. And you can see that's definitely a scatter plot. So step 2 is finding the mean point. And I'm going to explain how to do that, and then I want you to do that calculation. The mean point is just the mean of the x values and the mean of the y values. So we have a notation for that, and that's that mean point is written x bar over y bar. And so remember, x bar is the average of x, y bar would be the average of y. So go ahead and pause the video and figure out the mean or the average of the x values and the mean or the average of the y values. So what I did is I just pulled out my calculator and did my calc on my x bar, and I got 4.7 for the average of the time spent. So the average time spent studying was 4.7 hours, and then the average test score was 81.4. So the mean point is this, 4.7, 81.4. So we're going to graph that. So 4.7, right about there, and then 81.4, that's right about there. Now, this is not a data point, okay? It's a mean point. So we're going to designate that with an M, just so that we know that's not actually a data point. Now, the next step, and I want you to try this, is to draw a straight line that goes through the mean point that has an equal amount of data points above that straight line as below the straight line. So pause the video and do that. If you want to use a ruler, that's a good trick. Here's what I got. Here's my red line. I used red just to distinguish. You could use black, it's fine. And you'll notice that this line should really kind of split the data on both sides. Now there's a caveat here. The distance from the line matters, okay? So let's take a closer look. You can see that these points are below the line, and they're quite a bit further away from the line than the points on the top. And you'll notice that there's really only 3 points that are below, and we've got 1, 2, 3, 4, 5 that are above, but the above lines points are quite a bit closer than the ones that are below. So I've kind of split the difference between the data points. I'm about halfway between all of it. Plus the other thing is that the way the data is situated, if I tilt this line, it's going to be hard to go through this point and get exactly the same number of points above and below. And then when we do a regression analysis to come up with the equation of the line, the way it does that is it looks at the distances from the point to the line and it compares those mathematically to come up with an equation for a best fit line. Now that you've watched the video, take a moment to write down any questions so you can bring them to our next class. Always remember, you can watch the video again to deepen your understanding. If you enjoyed the video, please click like and subscribe.